Hi everyone, welcome back to the channel. In this video we will be covering the basics of Kangaroo for Grasshopper in Rhino. Now, Kangaroo, like all other applications, can be found at foodforrhino.com, and once installed you'll just see it up here along with your other tools. Now, Kangaroo is a live physics engine for interactive simulation, form finding, optimization and constraint solving. Now, we can have a look just up along the top row here once you do have Kangaroo installed, and you'll see all the goals along here. You can think of these as goals or rules. Either way, we need to pass some sort of geometry through these goals and it will be output by the Kangaroo solver. So what we're going to do firstly is we're going to put in a few of these rules or goals. So we will put in a load, an anchor, and we'll put in a length. Now once we have all of these three here in the middle, over on the left we need some geometry to put input through it. So we'll start off with just a point here. So we'll start with a point over here. Now you can think about it like this. I've sort of got it set up in three columns. On the far left we'll have our geometry. In the middle we'll have our goals, objectives or rules, however you'd like to think about it in the middle. And then on the far right we need to output all of that through Kangaroo. So for this video today, we'll be using the bouncy solver. I do really like using the bouncy solver a lot when showing people how to use Kangaroo because you can actually see the model working with momentum in time and it bounces around and goes through all its iterations, and you can see that in real time. You could also use the solver and you get the same result. But for this instance, we'll use the bouncy solver. If in the future, you are running a model and it is really slow, then just go for the solver. Don't worry about the bouncy solver. One last thing we need for this solver to work is we will need a toggle to be able to turn it on and off. So I'll just chuck that here. And then we will feed this point through the load, and then that load will go into our goal objectives. So we need to be working in a particular axis, so I'm going to be working in the Z axis, so I'll put the unit Z here, and then we do need an input of a certain amount, so I'll just start with 0.5. 0.5 for now. I do not want to do that. I want to enable that preview off. I need to turn preview off. Okay, cool. So I'll put that into the unit Z vector. So we have our force vector set up for that point. As you can see, it's not doing anything yet when I toggle that on and off. I'll just change the iterations. I'll go into further detail what these mean in the future, but just to show you how this works, I'll change that to 1. Yeah, okay, so we can see that flying off into the air. I'll just turn that down. There we go, so you can see it goes slower, it goes up, yeah. Okay, we can all see that. Cool, that's working. Cool. Now we can add geometry to the output of the bouncy solver, so where the lists are coming out of, we'll put a sphere. Yeah, we'll put a sphere right here. It's just so we can see it a lot better. We can see the solver actually interacting with geometry. We'll put another point in here just so they can interact with one another. Oh. Cool, so I got that set up, pre-golf. Now you can see they both have the same rules and values associated to them. You could drop it down, you could move it in a different direction, you could apply a different force at that point, but because you can see we're both feeding both of them through the same load point with the same parameters, they're both doing the same thing. However, if we take this point and run it through the anchor, as you would guess, even though they both run through our one point, because our one point is being anchored down, it's not going to move. And we can change that to negative and then drop that down. So one thing you need for the anchor, just make sure the strength is really high. If it's not, then that anchor point will get pulled and pushed around as well. And what we'll do is we'll join both of these points via a line, and then we will feed that through the line goal. And then what we'll actually do is also, this is actually not too complicated if you're only a beginner, but what we're doing here is we're adding the length, multiplication and slider together so that we can just use a slider to change the length of the line as the Kangaroo solver is running in real time, and you can see how that works. Rather than the line being a fixed point, we can just input the number like so. And then we will just join this length up into the goal objects as well, and we'll run the solver, and then as you can see, yeah, we can just slide this line along and the sphere will move along with it. Alright, now we will add a force back over here to this point, and we can see it move down and it will hold onto the anchor point, and basically what we've created is a pendulum. And you can see how you can play around with it in real time while the solver's running. So you can change the length, and you can change the force. You can actually just change the point, which point's the anchored point, and it'll all work in real time. So really, just a really powerful tool. And this is the basics of how you would want to set up a Kangaroo solver. Is on the far left side, you have all your geometry that you're going to input into your goals in the middle, and then over to the right, you have your output through the solver, and then you can output from your solver some sort of geometry that you can bake and then use in your modeling once you've got the result you're after. But yeah, just a really basic introduction to how the Kangaroo solver would work for you guys. Nothing too crazy at all going on, but we do have a pendulum working. So thank you so much if you've lasted to the end. Be sure to like and subscribe. I'll be putting out more videos in the next week or so, teaching you more about the Kangaroo solver. So be sure to check that out, and I'll see you then. Thanks.